Okay, so there we go. Our today's discussions only based on projectile motion. So one thing you have to understand, guys, is I'm going to teach you this topic in a such a way that you will be able you will be able to you will be able to answer almost any question on projectile motion. Okay? I want you to understand this topic. This is one of the simplest topic. Okay. So what is projectile motion? We have started. What is projectile motion? So projectile motion, when you hear projectile motion, it is just basically a motion in two dimension. Okay? What do we really mean when we say a motion in two dimension? Guys, when we're talking about linear motion, remember, when we're talking about linear motion, we are talking about an object moving in a straight line. That is linear motion in x direction. That's what we say linear motion. Then when an object is moving in y direction, that one we call it free form motion in y direction. Now, if an object is moving in both x and y direction, we call that object to be in a projectile manner. So the object is moving like that. As you can see, this object is moving in both x as well as in y. That is why we call it projectile motion. So projectile motion, in simple terms, we can say it is a motion in two dimensions. A motion which is moving in both x and y direction at the same time. That is basically projectile motion. Okay? Now, projectile motion, it all starts from where? From free form motion. The formulas for free form motion. Let me just give you the basic idea behind the free form motion. The formulas which we have for free form motion, we have the first formula is v final is equal to v initial plus acceleration times so now acceleration, in that case we say g, because in free form motion we are talking about the acceleration due to gravity. Then we also have the distance to be d is equal to v initial times t plus half g t squared. The last one, v final squared v initial squared plus 2ad. These are the formulas which you need to be familiar with under free form motion. Where there is a, I'm supposed to put g. Then when we're talking about free form motion, an object moving in x direction, where there is g, you replace it with a. That is acceleration, meaning an object is not moving under the influence of gravity. Okay, cool. So now one thing we need to understand, guys, is under projectile motion we have only three things which you need to be familiar with. There is the first trajectory, the second, and the third trajectory. Let's begin our discussion with the first case. I'll call this case 1. If you're behind, you need to ask. If you're behind, you need to ask. There we go. Case 1. Case 1 is a situation, guys, where you have a building and this is the ground. Okay? So you have got a ball which is here on top. Now, you are kicking this ball. And this ball is coming from the top of the building with the initial velocity to be 0. When you just throw something, you are not going to use any velocity. You just leave it. Okay? Okay, let's assume that you are holding something here on top. Just leave it. So it will be moving under the influence of gravity, meaning that the initial velocity at that point is 0. Okay? So this ball you are throwing just a bit. So it comes here and then it reaches there. What do we expect to have? The initial velocity at this point is 0. meters per second. So we expect to have this h, the height of the building, which we are going to call h. The horizontal distance is what we call the range. Okay, I hope we are together there. Under the first trajectory, the only things which you need to be familiar with is how to find the what, the height of the building, the time it takes for this ball to come from the top of the building all the way to reach down. Second, you need to know how to find the what, the range. Get me right there. Now, the initial velocity is 0. From these equations here, the three equations which we have here, we want to find the distance. These are the three equations. Our three equations are here. Our goal is to find the height. Remember, where there is d, you can replace it with h. It's okay. Guys, if I'm to use the second equation, which is d, now where there's d, I'll put h. I'll say h is equal to v initial times t plus half gt. Provided that you have been given the time we want to find the h. The initial velocity is 0. This guy has to go. So my h will be equal to half gt squared. This formula is very important. You can use it for the first trajectory to find the height. 1. Next, how do we find the time? I can find the time. I will derive the formula for finding the time using the same formula for height. So h is equal to half gt squared. Our goal is to make t as a subject of formula. What do we do? To get rid of half, let's divide it by 2. Sorry, let's do times 2 everywhere. 2 times h is 2h. 2 times half is just 1, so I'll have gt squared. Next, let's divide both sides by g. The most important formula which I want you to know, which I believe you will never write your exam or your test without using this formula. We are trying to make t as a subject of formula. Okay? So if I'm trying to make t as a subject of formula, since these formulas I've given you, I think for us to create space, let me just get rid of this. I want to make t as a subject of formula. So if I get the square root both sides, even here is going to be t will be equal to the square root of 2h, but this h, let's just say is a h max, meaning the maximum height of the building, divided by g. Guys, believe me, this formula is very, very, very important under the second trajectory, under the first trajectory. Now, in a case where you want to find range, remember, is the horizontal distance. The horizontal distance, the velocity will not change. In this case, you have not been given the velocity, but they will definitely give you the velocity. So the range is the same as we say the distance. Speed is equal to distance over time. So distance is equal to v times t. But which v are we talking about? The object, in this case, when we're talking about range, it is the horizontal distance. I'm going to specify and say vx. So d in this case is the range. I'll say r is equal to vx times t. Now, which t are we talking about here? The t we are talking about here is this t. So the t you are going to find using that formula is the t you have to use there. But the velocity for the first trajectory, they will always give you. This is the general idea, or this is the basic principle behind the first case, case 1. Before we continue before we go to case 2, can you ask me questions?
What's the key way to know that this question is actually one in the first case?
Okay. You are standing on top of the building. You throw a ball with an initial velocity of 0. Definitely, when you just hear to say a ball was thrown with an initial velocity of 0, or a ball was thrown with an initial velocity of 0, or it started from rest, just know that that is the first case. Have I made myself clear?
Yes, I clear.
Yes. So as long as they are talking about the initial velocity to be 0 at that point, then it is the first trajectory. But if you are going to be given the initial velocity and they have not given you any diagram, that will be another case which I'm going to show you here. Another question?
Sir,
Yes,
do
please.
they by any chance ask you to derive the equation?
No.
No.
Initially, all the formulas for projectile motion they are going to give you. But me personally, I've been teaching physics for the past 5 years. But still, if you come to me right now and tell me to, and you ask me to say, sir, I'm kindly asking if you can give me the formula for time for the first trajectory. Definitely, I'll not give you because I know them by driving them. So there are some people who are good in just knowing the formulas, but me personally, no, I'm not good. I would prefer to derive this formula myself. Is that cool?
Yes.
Yes. But for driving, no, no. They will not even ask you to drive these formulas. They will just ask you questions. That's all. Sometimes they can just ask you to say what
Do they give them
do they give what?
as
Yes, they give formulas.
they give the formula on the
Yes, they give formulas. The first even if you are writing a test, they will give you the formulas. They will give you formulas. But even if they give you formulas, Kai, you need to know that here I'm supposed to use this one. Not so. But they'll give you. Any question under? Yes.
Can you kindly explain what you just said again? I haven't understood.
I said they'll always give you the formulas under projectile motion when they ask you a question. Even if the question is not there for projectile motion, they'll still give you the formulas. They'll give you all the
No,
formulas.
sir, like what you solved.
You are from joining, right?
Yes.
So now see, you are from joining. So if we're just driving formulas, we have not started solving.
Oh, okay. Thank you.
Yes. So I think you catch up as we are. Okay. Any give me ask the last question before we go to the second one. Yes.
Sir, I wanted to ask,
Yes.
these formulas they give, are they derived already, or you're supposed to identify on this question and you're supposed to
Aha.
so
Yes.
just
You are supposed to know.
right?
Yes, you are supposed to know that on this question I'm supposed to use this formula. They will not tell you to say they ask the question then they give you the formula. No, the formulas will be there on top. All the formulas for physics. Even if the question is not there, they will just put all the formulas there. And then you need to know and understand. Okay, this question is coming from this.
Well, thank you.
Yes. Okay. So I think we go. We can go to the second case. That is case two. Oh, let me do this.
Then, sir, on case one, is there any difference between free for motion and case one?
There is no difference. It's just the same, because under free form motion we don't use angles. Even here we don't use angles, so it's the same.
Alright, sir. Thank you.
Okay, so now let me also show you something, guys. I want to show you something very important. mm, the thing which I want to show you is this. Okay. The first case, I'm not going to go to case 2 first. Before we even go there, I have to show you something. So case 1, there is a question which came in 20 for UNZA 2021 and 2022. They repeated that question from 2021. It came in final exam, and also 2022. Anyone who is having any paper for 2021 or 2022? I want to show you the question. I don't know if I have that paper, but let me check right now before we even go any further. If I have, I want to show you. It was case 1, but it was a bit complicated. People didn't manage to solve because of one reason, which I'm going to show you right now. I think it's this one. No, this is not the one. This is not the one, but I have to find it here. I have to find it. Okay. If you have the okay, I think I have now. I found it. This question came in 2020. No, this is not the one again. 2021 physics 1010. Was it this one? Was it this one? Was it this one? Was it this one? Exploring. A minute, just. Should be this one. Okay, yes, I found it, guys. So this paper, I know you can't see the paper, is for 2021 physics 1010. That should be question 3B. You're okay me reading the question just, right? So this will be more like I'm going to, I want you to know what's happening here, because maybe I should write the question. What do you think? But it's going to take time again. What do you think?
I think we just read it out.
Okay, let me read the question, I think, without us wasting time. So the question was an airplane carrying out a parcel drop releases a parcel while traveling at a steady speed of 90 meters per second at an altitude of 200 meters. An airplane carrying out a parcel drop releases a parcel while traveling at a steady speed of 90 meters per second at an altitude of 200 meters. Calculate part A, the time between the parcel leaving the airplane and it striking the ground, that was 5 marks. Part B, calculate the horizontal distance traveled, 5 marks. It had 10 marks. Let me read the question again. An airplane carrying out a parcel dropping release a parcel while traveling at a steady speed. So as it was dropping, this is an airplane here. So this airplane, it was moving at a steady speed. When we're talking about it was moving at a steady speed, there is a velocity which was moving in that direction, okay, which we have been told that is 90 meters per second. Get me right there. Then, as the airplane was moving in that direction, the parcel released from here, it was going like that. So this is the ground. Then we have been told that the distance from this point here where the airplane was all the way to the ground, that is the altitude, it is 200 meters. I want you to be very much careful here. I want you to understand what's happening. As it was going in this direction, this velocity here, it was the velocity of what? The airplane. But, and this velocity, it is the velocity in x direction. But as the parcel is dropped from here going down here, the initial velocity is still zero. Get me right there. So the initial velocity in y direction is still 0 meters per second. Then the 90 meters per second is the velocity in x direction. Okay? Which is 90 meters per second. So this question, a lot of people didn't get it right because they thought maybe 90 meters per second is the velocity in y direction. Because the question is, an airplane carrying out a parcel releases a parcel while traveling at a steady speed. It was dropping the parcel, but it was still moving. Okay? While traveling at a steady speed of 90 meters per second at an altitude of 200 meters. That is the distance from the ground all the way where the airplane was. The first question is, calculate the time between the parcel leaving the airplane and it striking the ground. So we want to find the time it takes for this parcel to release from here all the way striking the ground. Which formula are we going to use? From what I've been from the explanation I gave you under case 1. Tell me fast. Yes.
I think it's part one. You said that you should really master it. T is equals to square root of 2h over T is equals to square root of 2h. H squared is I. So was it over T? Yes, over the
Over G.
over G.
Yes. There is no need of you driving the formula here. Even if you just want to come direct here, still you are going to be given 5 marks. If you want, you can drive the formula. That is just okay. You say H will be equal to D V initial times T plus half GT squared. You still end up coming there. You want to find the time. T will be equal to the root of, but this formula they don't give. Let me not lie to you. This one, they don't give. You need just to know it. So it is 2 times 200 divided by 9.8. So from today onward, when you are coming for physics, learning physics with me, you should always have a calculator nearby you. So 2 times 200 divided by 9.8, then the square root of this is 6.388, which is the same as 9 seconds. This answer was 5 marks. Just doing that. Projectile motion is one of the simplest topic, guys, as long as you understand the concept. Next, another question was, where is it now? Another question is, calculate the horizontal distance. The horizontal distance is the range. The moment you hear horizontal distance, you're talking about range. So I told you to say range is given by Vx times t. Do we have Vx in this case? Do we have Vx in this case? Yes.
I think Tx is 90.
Nine,
90 meters per second.
yes, 90. 90 is my Vx. Times. The time is the time you have found here, guys. Don't forget. So the time is 6.39. So our range will be 90 times 6.39. As simple as that. 90 times 6. You can mute your mic. You can mute your mic. 575.1 meters. 5 marks. Just doing that, I don't think there is anything difficult. So this is another part which I want you to know under projectile motion case 1. A lot of people, they get confused. So understand the question first, and then there was no diagram. And most of the time, sometimes you are going to be very lucky if they give you the diagram under projectile motion. Is that okay? Any question, guys? Any question?
Sir,
Yes, please.
the altitude, the 200 meters.
Mhm.
How are you supposed to know that it's the range, the distance in y?
Okay. So the way you are going to know, the question it was saying that it was traveling. It was traveling. Uh, they are saying that an airplane carrying out a parcel drop releases a parcel while traveling a steady speed of 90 meters per second at an altitude. So what does the word altitude mean? Hmm? Okay, so altitude is the distance above the ground. So should we say they were just supposed to specify to say, given that the distance from the ground to where the airplane is 200? Why have I put 200 meters per second here instead of just 200 meters? So altitude is the distance from the ground all the way to where that object is. That is the altitude. So that's how you're going to know that this is the distance in y direction. Is that okay?
Yes.
Yes. Can we go to case 2? Or you still have questions under case 1? Hmm? Do you still have questions under case 1?
So in a case where the horizontal distance,
Mhm.
I mean the going to the speed in the y direction is not given, then you have been asked to find the range.
In a case
In
where
that case, like
in a case where the what, sir?
30, 90 meters per second, which has been given,
Okay.
what is the dynamics of
Uh,
two moving?
okay. So they'll always give you, as long as you they'll always give you the velocity. You can't find the range without the velocity in x direction.
Okay, okay, okay.
Someone was asking about, sir, what happened as with physics 1015? Are the topics the same? Do you know that physics 15, 1015 and 1010 is the same? There is no difference. Like literally, there is no difference there. The only difference is just to specify that these other guys are doing health programs. These other guys are just are doing the programs from main campus. That's all. There is no difference. There is no difference. Okay. So now I think we can have 1 minute break, right?
Sir, I just wanted to ask, is there
Yes.
any situations where I can be given, maybe they haven't even given the pattern, and they say where they, okay, just where they can give you a situation with an object that's being shown with an initial velocity not given, maybe
Okay.
pattern given.
Okay. Okay. I get you. Okay. I'm going to explain that. Okay. So let's just have a 1 minute break, which I believe initially, guys. I know you guys who have been watching our videos on website. Sorry, on YouTube. But there are some videos on YouTube which I know sometimes you have come across some certain videos where when you want to watch they will tell you to say only members can access this video. Have you ever come across such? on our YouTube channel? Anyone who have?
Yes.
Yes.
I came across one under stoichiometry.
Uh-huh.
There was something I wanted to watch then.
Exactly. So now what's happening, guys, there is this. On YouTube, we do post videos which I believe they have been so helpful, and I know that. But there are some more videos which can help you to understand fully on that topic. So we have got a website which, when you, I believe when you go on Google, as long as you type transcended, as long as you go on Google and type transcended institute, definitely you are going to see something like this. You are going to see something like this, whereby when you click here, it will lead you to this website. Guys, believe me, this website, there is nothing like I'm behind. There's nothing like you are behind or you are not behind. This website here is designed in a such a way that all the videos here, they are there. Let me give an example of, if we go to physics right now, or if we go to chemistry. So if I go to chemistry right now, guys, you are going to discover to say all those videos which are telling you to say only members can access from there. The people who are registered with us, they will be able to access these videos. Stoichiometry. These videos you see here for stoichiometry, only part 1, 2, 3 are the ones you are going to see on the YouTube channel. These are the ones you have been watching. But these ones, as long as you are not registered, all these ones down here, you have never watched them. Believe me. All those videos under stoichiometry, you have never watched them. To throw sheet 1 solutions, to throw sheet 2 solutions under stoichiometry. These are the videos such that when you go, maybe you go by the basement, you can download them. We have got an app where the app is here. When you just come here, there is an app here, download app. When you download this app, you can download these videos. Let me give one example. If I go on concentration molarity, if I click there, I can download this video. When I go back to my room, I'll be able to watch it without using my bundles. Get me right there. I can, here where it's saying save for offline, you click here and it's going to be downloaded. Do you want to download this? Then I download. You download this video, and then when you go to your app which you have downloaded here, you are going to find these videos. They are arranged there in a proper manner. Then you'll be watching them at your own free time. But these videos, you can't download them to be in your phone or in your device. But you can just, more like YouTube, you can just download them as offline, and then when you go to your room or you go to anywhere, you are going to be watching them without using bundles. I think you know what I mean. So now, before we even go back, we also have, when you click on open document, the tutorial sheet, there are some tutorial sheet here, especially for this year. We have solved them and they are already there. When you click on document, you are going to find them. They are in PDF form. Very soon we are going to be posting even notes. For those who are going to be registered with us, when you want to join the class, when you say there's a chemistry class or math class, you just click on join Google Meet. Then you find yourself, we are together there. We are learning. When you scroll down here, you are going to see that we also have the past papers, the chemist past papers. For each course, we have got past papers: math, chemistry, biology. Here for chemistry, if I come here, you are going to see that there are past papers here. The paper for 2022, we have the solutions. Same applies to physics, math. The last year's paper, we have them. We have already solved them. Such that when you learn each and every topic, you just on past papers. Okay, let me revise today. You go on past papers. you come here, down here, you find all these are past papers for Onza. I solved all the past papers from 2017 all the way to 2023 past papers. All these videos, all these ones, you just enjoy both 1015 and the 1010. We go back to our main business now. If you have got any question you are going to ask me, but let's go back to our main business. Let's now talk about case 2. So after this, if you want to register with us, because these are free classes which I'm teaching you right now, which I think tomorrow it will be the last free class. If you want to be with us, get in touch with me. Here is the number: 0767 729927, Transcended Institute. Believe me, we are going to be together up to exam. Okay, so let's go back to case 2. Case 2 is a situation, guys, where you kick a ball from the level ground. What happens to this ball? Here is a ball. You kick it, it goes there all the way, it reaches there. Now, you can't kick this ball without the velocity. That's what you should know. You always have the velocity. You always kick this ball at an angle. Get me right there. The angle is theta. Are we together? Are we together there? The angle is theta. One thing you have to understand, guys, is that we are going to have something like this. It's like we have got our velocity here, the angle is here, meaning that this is Vx and that is Vy. What does it mean? Under vectors, I believe we were doing together vectors. When we're talking about Vx, Vx is V cos theta. Vy is V sin theta. Before we continue, I don't want to leave anyone behind. If you are behind a bit, let me know. If you are behind a bit, let me know. Okay, cool. So we are going to have the height from here all the way to there. That height is our H max, maximum height. The horizontal distance is what we call the range. I explained this. So now, using those formulas, one thing we have to understand is that we need to come up with the formula for finding time. Allow me to denote this to be part A, part B, part C. We need to know how to find the time. We need to know how to find the range. We need to know to find the H max. Let's go ahead and start finding the time. When you want to find the time under the second trajectory, the moment you hear to say a ball was kicked from the level ground, just know that we are talking about the second trajectory. A ball was kicked from the level ground. They'll give you the angle, even sometimes the initial velocity. Sometimes they can hide the angle, but you start playing around with the formulas until you find that angle or the velocity. Okay? So I'm going to use the first formula, which is V final is equal to V initial plus GT. But one thing we have to understand is that we're not talking about we want to find the time. Since it was going up, we have to specify this and say the Vy final, the Vy initial plus GT. After doing this, the next thing we have to remember is where there is Vy. Now, when the ball reaches at point B, as long as it is in that direction, in y direction, when something reaches at the maximum height, since this is h max, the final velocity at that point is 0. So this guy will be 0. I'll say 0. Now Vy according to this is V sine theta. So I'll say V sine theta is plus. Now G, since something is going up, when something is going against the gravity or going up, G is negative times T. Then let's shift this to the other side. So it will be negative V sine theta is equal to negative GT. Our goal is to find T. Let's divide both sides by negative G, even here by negative G. So these two will cancel. Negative and negative will go. Therefore T, this T we are talking about is from the T from A to B. So the T from A all the way to B. Okay? The T from A to B will be equal to V sine theta divided by G. This formula is very important, guys. You have to know it. So if they ask you to find the time it takes for it to reach at the maximum height under this trajectory, you use this formula. Now, if they ask you what was the total time meaning is from T, the T from A all the way to C. So now, the time it takes from A to B is the same as the time it takes from B to C. Therefore, if you get this times 2, that is the time. So if I just say 2 V sine theta divided by G, then that's the total time. Before we go to the next one, ask questions. Okay. So the reason why we are getting the direction in y-axis, because we are finding the time and we know that as it was going here, it was moving in this direction. So in this case we are getting y. We are getting y because this was being thrown in this direction. You get my point, right? So we are not, for now, we are not interested in the distance in what? The velocity in x direction. We are only interested in the velocity of x direction when you have been asked to find the range only. That's when you are going to use the velocity in x direction, because that's horizontal. But in this case we are interested in what? The vertical component, because the height is in what? In vertical component, which is y-axis. Have I made myself clear?
Sure, sir.
Okay. Or in other words, what I can tell you is this. I think I gave you something like this. So we said this is V and this is X, Vx, and that's Vy. That's theta. So when something is going up, like in this case, this ball was going up until it reaches at the maximum height, it comes down, meaning we're dealing with y. When something is moving in this direction horizontally, meaning we're dealing with Vx. I think I've made myself clear there. Okay, so allow me to put these formulas here. Where should I put this formula? We are saying T from A to B is V sine theta divided by G. Simple. Now another thing we have to know is how to find the height. So how would we find the height? This one comes from h is equal to, or let me say, it comes from v final squared is equal to v initial squared plus 2g, we say 2gh. In this case, h is the h max we want to find. So when we're talking about the height, meaning we're talking about the y-axis. But remember, since at point B it is at maximum point, meaning the final velocity at maximum height is 0. So that will be 0. This will be v sine theta. But everything has to be squared because it is squared plus 2. Now, since it was going up, g is negative. But this one we are going to be given, the formula we are trying to derive. Even the one for the time, this one they will give you. So what I'm going to do now is, I'm going to shift this to the other side, meaning I've got negative v sine theta squared is equal to, this will be negative 2g h max. Divide both sides by negative 2g, even here by negative 2g. So these two guys will cancel out. I'll remain with my h max to be equal to, the negative will cancel. If I bring the 2 inside, it will be v squared, it will be v squared, then sine squared theta divided by 2g. So this is the formula for finding the h max in the second trajectory. Now, in most cases, you are going to have challenges on how to punch on your calculator here. I recommend you just put this direct here, just use v sine theta. The answer you're going to find, just square it, then divide it by 2g. As simple as that. The last thing we should have to know now here, have you gotten the point there? What I've said? Yes. The last thing we should have to know, guys, now is how to find the range. The range here, I want to make things clear to you. How do we find the range in the second trajectory? Remember, we said range is equal to Vx times t. What is Vx? Since we have been given the angle, Vx is V cos theta times t. The t is the time it takes from A to C, which is this one. Believe me, no one is going to penalize you if you use this formula direct here while finding the time there separate and plug in the values there and find the range. No one is going to penalize you. But I want to make things complicated a bit. I just want to derive the formula for range, which you are going to see maybe in your in the question paper. There we go. Can I just get rid of this a bit? Okay, let me put this one here. Let me put this one here. I put the formula down here to make things simple. I think let me just get rid of this a bit just. So R is equal to V cos theta, and we know that T is given by 2 V sin theta divided by G. R will be equal to, so if I do V times V, I'll get 2 V squared D. Cos theta and sin theta is going to be sin theta cos theta divided by G. When you reach on trig math, and I believe I'm the one who is going to teach you trig under math, you are going to discover that 2 sin theta cos theta is an identity which is replaced by 2 by sin 2 theta. So therefore I can replace this 2 sine theta cos theta with the sine 2 theta, which I believe you are going to see this divided by g. So this is the formula for finding the range under the second trajectory. The one who asked me the question if you have been given the initial speed for the first trajectory, I think I'm going to teach you that under freeform motion, the day we're going to do freeform motion. That's the day I'm going to explain that, because the first trajectory is the same as the freeform. Is that okay? There we go. Last but not the least, you're going to find this a very interesting question. Find the speed just before it hit the ground under projectile motion. How do we find the speed just before it hit the ground? So the trajectory is this one. Then you want to find the speed just before it hit the ground. What does it mean? You have the y component there, the x is also here. Just before it hit the ground, they will meet there. The angle which you are going to find, they will ask you to find the, sometimes they'll ask you to say find the speed just before it hit the ground. How would you find? Get me right there, guys. You have to find the speed in y direction. You have to find the speed in x direction. How do you find the speed in x direction? You say v final in x direction is equal to v initial plus what? Should we start with x direction or y direction? You can choose. We start with x. Okay. So we start with x. Now we want to find the velocity just before it hit the ground. This is the most interesting question which I want you to know today without hesitating here. So for us to find the speed, you are going to discover to say, to find the final velocity, it will be the same as, since we are saying we want to find the vx, right? In short, the velocity in x direction, I think you have heard this. I know you have been learning physics for some time. The velocity in x will not change. It will be the same. The velocity you have here, if it is 2 meters per second, you still have the same here. Is that okay? So to find the velocity in x direction, you need just to find the x component of that velocity. So vx will be equal to v cos theta. That will be the velocity in x direction. It will not change. The only velocity which will change is the velocity in y direction. But let's go and see how we can find the velocity in y direction. There we go. So v final in y will be equal to v initial, okay, v initial in y, then plus gt, like that. Is that okay? Now the question here which you have to ask yourself is this. The question which you have to ask yourself is this. Which initial velocity are we going to get? And now, I'm now asking you that question. I'm now asking you that question. Which initial velocity are we going to get? Did you guys do projectile motion, or this is the first time you're doing this?
That's deep, but I didn't understand.
But now you are getting something, right?
Yes.
how we did, but the way it is done,
Yeah, I
it is done.
understand. I understand. So where are you in physics right now?
As we in and energy.
I want you to help me with um, the group which is very very behind. Can you manage to find out for me the group which is behind in physics? Because when you are writing test, they will be following that group. So even if you rush, there is no need of you rushing. I think the last group can be on what, the way you see it.
I think it can even be us because we are on projector. We just finished. Then we want to start
Newton's laws.
law.
Okay, Newton's laws is one of the biggest topic, guys. Let me not lie to you. Someone who is going to understand Newton's laws of motion, believe me, all the Newton's laws of motion is going to help you to know work, energy, and power. Is going to help you to know linear momentum. Is going to help you to know circular motion. Is going to help you to know rotational work, energy, and power. Is going to help you to know mechanical properties of matter, which is the last topic for physics at once. So, believe me, don't run away from Newton's laws of motion. The main topics in physics, Newton's laws of motion and vectors. Here I'm using vectors for me to resolve this. Once you understand vectors and Newton's laws of motion, believe me, the rest of the topics is going to be easy for you. But if these two topics are going to give you nightmares, no, it's going to be hard. So make sure you understand vectors and make sure you understand Newton's laws of motion. Once you understand those, then you are okay. Okay? Yeah. So once you understand those, then I don't think you have any challenge with physics because you just connect the principle. Someone who understands Newton's laws of motion, work, energy, and power, you can even do it in one day. You can manage to solve all the questions just in one day, all the past paper questions, as long as you understand work, energy, Newton's laws of motion. It's very easy. Okay. So now, when finding the velocity just before it hit the ground, so you are going to consider to say the initial velocity, you get the one you are going to find here for v sine theta. So we'll say this, this one we don't know, and then we are going to say v sine theta. Now since it is going up, in that case you put minus gt. When you find the answer, remember your vx is that one. When you find the answer, which I believe sometimes you can find a negative, sometimes a positive, it doesn't matter, which I believe in most cases is negative. In most cases is negative. So you find that the velocity just before it hit the ground, you find is going to be the square root of vx squared and vy squared. So vx is the one you find here and vy is the one you are going to find using that formula. That is under the first trajectory. And mostly they ask these questions under this first trajectory and third one. The first one or the second trajectory and the third one. The first one, no, they don't like asking. These are the things you need to know under the first trajectory or the second, sorry. I'm even tired now. So I think for today we end there. Then tomorrow we finish with the third trajectory. Then I want us to solve all the questions I think from past papers, which I believe I solved them already, but we're going to solve them again. Then the tutorial sheet for projectile motion for 1010 and 1015 is already solved. The videos are already there. So if you want to access, I think you have gotten my number. So for those who want to contact me, that's the number: 0767 729927, for those who want to contact me. So the time we're going to do Newton's laws of motion, okay, that's my favorite topic, so I believe each and everyone is going to understand. That's my favorite topic, because I know that once you understand Newton's laws of motion, then physics is going to be easy for you, because that's the motherboard of physics.